So problem 21 in your textbook, it says what is the period of revolution for a 9,500 RPM centrifuge and a 9,500 RPM computer hard disk drive. Okay. So for problem number 25, or 21, I'm sorry, we have a 9,500 RPM, that's revolutions per minute. In fact, they're both 9,500 RPMs. The first one is a centrifuge, and the second one is a hard disk drive. So this one's a hard disk drive, and this is a centrifuge. What do you notice about that word centrifuge? What does it look like? Centrifugal, which is an effect, right? So it uses centrifugal effect to take the more dense material, is that grammatically correct? Denser material, and it forces it to the bottom of the test tube depending on how it looks. So what we're asked, this is not that hard, but it says, what is the period? Okay? What is the period? So I guess what I want to ask you guys, it's a little bit simpler if we go through and we try to figure out some of these things. So what I'd like for you guys to do is I want you to turn to page 256 and 257 of your textbooks. It's actually right at the top of 257. So in your textbooks, go to page 257. And so there is a relationship. So what they want to know is, well, first let's write down the relationship. The frequency is equal to 1 over t, or the period. Right? So t is the period, and that's what they're looking for. And f is the frequency. And so, oh great, Mr. Adams, now that we know what the period and the frequency are, what does that mean? Now, who remembers from their notes what is the definition of a period and what is the definition of frequency? Does anybody remember that from your notes? Well, I guess, what section was that from? Looking at page 257, do you remember what it is? Yeah. Go ahead and say it.
Period is time for one rotation, and frequency is rotations per second.
Okay, so period, let's do period. What did you say it was? 1 revolution? Or 1 rotation?
Yeah.
And what did you say frequency was?
Frequency is rotations per second.
Rotations per second. So the frequency is rotations per second. Okay? So they're asking for the period, which is the time it takes to complete 1 revolution. Does that make sense? And frequency is the number of rotations per second. Now they vary inversely, and this is their mathematical relationship. All right? So the reciprocal of the period is the frequency and vice versa. Well, what they gave us was RPMs. Well, it's the same RPM for both of them. So I have 9,500 revolutions per 1 minute. So now when I go back here and I look at this, all right, they're asking for the period, which is how long does it take to do 1 revolution? And the frequency is how many rotations per second, or revolutions, right? One rotation, revolution, they're kind of interchangeable, right? So what do you guys suggest we do? Well, if I could get some number of revolutions per 1 second on the end here, that would be nice. So how do I do that? Maybe if I hit this with a conversion factor? Well, how would I do that? So 1 minute is equal to how many seconds? 60 seconds. So what is that then? What's 9,500 divided by 60 seconds? Somebody do that on their calculator. I'm going to grab my... Normally I do the calculator on the screen, but today I'm just going to do it by hand because we're just going to do simple multiply, divide, subtract, and all that stuff. So if I say 9,500 divided by 60, I'll get 158. So I've got 158 revolutions per 1 second. Now what did I just find? That's the frequency. What were they asking for? The period. How do I find that? Yeah. So our equation is T is equal to 1 over F, right? If you were to algebraically manipulate that, which is equal to 1 over 158. Now remember, this is revolutions per second. Oops, there goes my calculator. So what's 1 divided by 158? Does anybody want to tell me?
0.006.
Yeah, it's approximately 0.006. So, T equals 0.006. Now, when I divide by this number, I really multiply, like frequency is a time, and so I've got the revolutions cancel, right? So, you've got to, this is in seconds, okay? Does that make sense? Because it's second per 1 revolution. It's really seconds per revolution, right? So it's really like this per revolution. But by definition of what the period is, we're only interested in the time part, right? Now, how do I write that in scientific notation? Yeah, 6 times 10 to the negative 3 seconds. Any questions on that? Now, they gave us 2 examples. They gave us a centrifuge, and they gave us the hard drive for the computer. Does it make a difference? Should be the same for both, right? Why do you think they did that? Because you may be tempted to look up the radius and think that this has to do with the radius. It doesn't, because it's angular velocity and rotation. If I take a great big huge circle and I do 1 revolution in a minute, and then I take a very tiny small circle and I do 1 revolution per minute, they'll still have the same frequency and period, because it's based on revolution per time. Now their angular speed, well, not their angular speed, their tangential speed will change quite a bit, and that's dependent upon the radius. Does that make sense to you guys? Okay. Let's stop recording that one.